Hi. Well, I'm going to talk in this video about the forces involved in mowing the lawn. As I'm sure you can tell from this excellent drawing, this is a lawnmower and this is a person pushing a lawnmower. And there's a bunch of different forces involved, and there's also some trigonometry involved. So first I'm going to start off by making a free body diagram for this situation. Free body diagram doesn't actually require a drawing of the lawnmower or the person. It requires a dot for the center of mass of the object that you're pushing around, and then arrows showing all the forces acting on that object. So the first and obvious one that I've got for a lawnmower is gravity. So there is a gravitational interaction between the earth and the lawnmower that pulls it straight down. That's what we call the weight of the object. There is also a force pushing up on the lawnmower. It is a contact force between the ground around the lawnmower and the mower itself that pushes it straight up. If that force wasn't there, if gravity was the only one acting on the lawnmower, it would start accelerating downwards, crashing through the ground. That doesn't happen, so that tells me there must be another force that points straight up that counteracts that. Okay, then I've got also friction. So there's friction between basically the tires and the ground, and that pushes backwards, trying to slow it down. So I'll make that one point backwards. That is a contact force, actually I'll put an F there for friction, between the ground and the mower. It's trying to slow it down. And then the thing that's actually causing it to move is you pushing on it. But you're not pushing either straight to the right or to the left or up or down. You're pushing along that handle. That is at an angle that points down towards the mower like that. So I'm going to draw that one, and I'm going to draw it in red still over here. That is acting that way. That is a contact force between the person, and the mower, and that acts at an angle. So what we want to do is we want to figure out what's going to happen to that lawnmower and some things about the relative sizes of all those forces. So an important thing about mowing the lawn is that it's actually kind of dangerous to have acceleration involved with a lawnmower, because if it starts accelerating forward in the direction you're pushing, you're going to lose control of it, and because it'll keep getting faster and faster and faster, and you don't want that. You also don't want to have acceleration the other direction back towards the person, because that means it's like you were pushing it and it's accelerating, which means it's going to slow down. You actually want it to be moving at a constant speed. So you want the velocity to be constant. If you want the velocity to be constant, that means you want the acceleration to be 0. And if you want the acceleration to be 0, that means that what you want is for the sum of all the forces. So you add them all up, you want that to be equal to 0. Sum of forces equals 0. That symbol that I just drew is a Greek letter sigma that means sum. If you add up all the forces, you need to get 0 in order for there not to be any acceleration. So how is that possible? Well, what that's going to mean is that all of the up and down forces exactly cancel each other, and all of the left and right forces exactly cancel each other, so that the total force adds up to 0. Okay, well, how's that possible? Well, I've got this force from me pushing at an angle. That must mean that the easiest way to think about this is going to be break up that diagonal force that doesn't line up conveniently with the grid into one that does conveniently line up with the grid. So I'm going to break it up into two pieces. There is a piece that points horizontally to the right. That is the thing that is pushing forward. And that piece must be exactly equal to the friction in order for there to be no net force either left or right. And then there must be another force that points, let me make it that pinkish color, that points straight down, that together with the gravitational force, these two are downward ones, must exactly equal to the contact force pointing up. If that weren't true, then the lawnmower would either be accelerating upwards or downwards. Okay, so we got to figure out how that's possible. So usually, especially in physics problems, these things are expressed in terms of angles. There's this handle is at an angle to the ground, like so. Let me redraw this with the same colors over here. that this is an angle right here. So if that angle right there is theta, that's the angle between the ground and the handle, that's the same angle over here. The angle between the ground and the handle is the same on that side, even though I've drawn it slightly differently. It's a good idea to think about why that's the case, thinking back to your geometry or other math classes. Okay, so the force that you push with is a force that you push with. Let's say it's some number. Let's say it's like 300 newtons. That's how hard you're pushing. Let me kind of highlight it in red so we can see it's that same force that's along the diagonal. That's the hypotenuse of a right triangle. If that's the hypotenuse of a right triangle, then I can use sine and cosine, SOHCAHTOA, to figure out what's the blue side, that's the horizontal one, what's the pinkish side, that's the vertical one. Okay, so SOHCAHTOA. So let me just write down what those are. The sine of the angle is equal to the opposite side, whatever that is, over the hypotenuse. I wrote it in that pink color because the opposite side to that angle is the pink one. And then blue, I'll put in blue, the cosine of the angle is equal to the adjacent side over the hypotenuse. And the adjacent side is that blue one. So I can use those two trig relationships to figure out how big the adjacent side and the opposite side are. Okay, so let's set up those relationships. So the cosine of the angle, whatever that angle is going to be the opposite, is going to be the adjacent side, that's the horizontal one, divided by the 300 newtons, that is the applied force. Okay, that means that the adjacent side on that triangle is going to be equal to 300 times the cosine of the angle, whatever the angle is. And then same thing for the vertical one. The vertical angle, the vertical side, is going to be equal to 300 times the sine of the angle. And sorry, that 3 got messy there. Okay, so in order to figure out how big the adjacent side is, I'm just going to plug in whatever the angle is, take the cosine of it using the calculator, and multiply that by 300, and I get the blue side. To get the opposite side, the vertical one, I take whatever the angle is, plug it in with the calculator to find the sine of that angle, multiply it by 300, and then I get the vertical side. And what I've learned is, looking at this this free body diagram, that pink side plus the gravity has to equal the contact force pointing up. That must be true in order for it to be balanced and not accelerating either up or down. And then the blue side has to be exactly equal to the friction in order to keep the horizontal forces balanced, so the mower will neither accelerate forward nor backwards. So summarizing all of that, that means that the friction in this case, the friction between the ground and the mower has to be equal to 300 times the cosine of the angle in order for it to be balanced. If the friction happens to be smaller than that force, then it will accelerate forward. If the friction happens to be bigger than that force that I'm showing here in blue, then the mower will accelerate backwards and slow down. And then looking at the vertical ones, what I've learned is that the gravity, the interaction between the earth and the mower, plus 300 times the sine of the angle, which is the opposite side of that triangle, because those are both pointing downwards, so they add up, has to be equal to the contact force between the ground and the mower. If it happens that the contact force between the ground and the mower is bigger than those two put together, that's going to make the mower accelerate upwards. That might happen if it bounces off the ground somehow. If, on the other hand, what's on the left-hand side of this equal sign happens to be bigger than the contact force, that means the structural integrity of the ground has broken down and it is accelerating downwards. That happens if you like hit a weak spot or a pothole or something like that, and it breaks down through the surface. Okay, so in order to like really figure out exactly what's going to happen to the mower in a certain situation, I would need to have some numbers in there for how big the gravity is. I would need to have a number in there for the angle to figure out exactly how big those vertical forces are and the horizontal forces, and then you can figure out the relationship between the friction and the other ones.